Hey everybody! I just wanted to spend a little bit of time talking about Chapter 3 to help us get in a good position to make good time and cover what we need to cover before the exam next Wednesday. So there are some sections that we are going to skip. You can go ahead and read those if you'd like. So a lot of early fetal development, I'm not really going to spend a lot of time on. But if you are interested in reading those, I would recommend doing so. So I want to spend more time focused on what infants all the way up through childhood and older adulthood can do. We're going to spend most of our time talking about children and infants, but anytime that you're looking at changes over time, whether they are physical in nature, cognitive in nature, or social in nature, you are fundamentally dealing with developmental psychology. And so the basic question that developmental psychologists will ask is what shapes the way that we change over time. So we're going to start by talking about abilities that we have in infancy. Now, occasionally I will get somebody who says, Dr. Gilchrist, I remember being born. You probably don't. Your brain and especially your vision do not have the capacity to build that kind of memory at that point. Odds are pretty good if you remember something from your birth, it is based on a memory that somebody else had and told you. Because one of the things that we know is that our memories are often reconstructions and they often integrate information that other people have told us. So we know that infants have very poor vision at birth. They can't even judge the appropriate distance to be able to see in 3 dimensions until months later. But despite that very poor vision, they do have senses that are better. So we know that they can discriminate even in the womb. They can discriminate the voice of their mother from other voices or from strangers' voices. They will often prefer the scent of their mother over the scent of a stranger. And they have an inborn preference for sweet tastes compared to things like sour tastes. If you ever want to watch something kind of funny, go watch videos of children eating lemons for the very first time. It is hilarious to watch a baby eat a lemon. They don't understand what they're doing. In addition to their senses, we know that infants have a variety of different reflexes to help them. So one that you are probably very familiar with is the grasping reflex. So if you put something in an infant's hand, they are suddenly going to start to grasp on it with a lot of force. And their grasp is so strong that you can actually pick them up by their hands. Now you have to be careful because they haven't really developed their neck muscles at that point. So when you pick them up, their heads are going to be like this all the way back here. They're not going to have that support. In addition, we also have something called the rooting reflex. If you gently brush the side of an infant's face, they will purse their lips and prepare to suck because that is how they feed. In addition, they do tend, as I mentioned, they have a preference for the scent of their mother compared to other senses. They also seem to have a preference for faces. So you are looking at 2 images. They have the exact same items in these images. The only thing that has changed is the configuration. We find that infants prefer to look at this configuration versus this configuration because this one actually makes a face. So let's spend a little bit of time with the time that we have left talking about the brain and development. So one of the things that you might be surprised to know is that when you are born, for the most part, you are basically born with almost all of the neurons that you're ever going to have. Now, am I saying that adult neurogenesis doesn't happen? No, it does. But in general, adult neurogenesis doesn't produce as many neurons as the ones that you come in with. So You might be asking yourself, well, why is it that my brain gets so much bigger if I'm born with all the neurons that I'm ever going to have? The reason for that is that you have not gained enough experience to begin those neurons building connections with each other. So one of the things that we find that contributes to the massive increase in brain weight and head size throughout childhood is not a change in the number of neurons. Those are always going to be the same. Rather, it is the connections that are being built between neurons. Remember that I said that neurons learn and grow and build connections through experiences. When you are an infant or you are a child, you are getting all of these new experiences. And it's through those experiences and that exposure to the environment that these connections begin to grow. So you can kind of see here with cortical neurons, here's what they look like at birth. You can see that the number is still there, but the connections have densely changed by 3 months. Here is a year and 3 months. So by a year later, you can see that those connections are far more dense and they are contributing even more to that brain weight and that brain volume. And this is especially true for our frontal lobes. So what we're going to find is that those connections are going to build very quickly. And then over time, we're going to discover that some of these connections we need and some of these connections we don't need. So we are going to prune any connections that don't really serve us. So we're going to have this rapid connection, and then around 6 or 7 years old, some of that is going to get pruned. In addition to brain development, we do also see that there is some motor development that changes as well. Now, one thing that I will mention when we talk about development is that there is going to be some variability in when people start to do these things. Some infants learn to walk at 12 months. Some infants learn to walk at maybe 13 months. Some infants learn to walk at 11 months. So there is some variability as to when people begin these stages, when infants begin these stages. But by and large, regardless of when you start a stage, they always follow the same sequence. So by and large, on average, your infants will sit unsupported at 6 months. They begin to crawl at 8 or 9 months. They begin to take their first steps and walk by 12 months. And by 15 months, they are walking pretty independently. So every infant is going to hit those stages at a different time. But by and large, that sequence is always going to be the same. And it's largely prevalent across cultures. So something you might be kind of surprised to think about is that I mentioned that you probably don't have the capacity to remember being born, but it turns out that you do have the capacity to form memories in infancy. So what you're looking at here is work by Rovi Collier, where an infant's foot is being tied to a mobile. Now, one of the things that you need to know is that babies really like novelty. They like new things. They like things that move. They like things that make noise. So the researcher basically put the infant in a crib, and this had a mobile with different types of shapes, and they tied a ribbon around the infant's foot. So if the infant kicked, that would make the mobile move. Now, initially, if this happened, it happened on accident. But over time, the longer that the infant was in this session, they would learn that kicking basically makes that mobile move. And what's really amazing is that when you take the infant out of this scenario and bring them back a few weeks or a few months later, they have remembered that kicking will actually make that mobile move. So they are capable of forming memories. I even remember, odds are pretty good, if you talk to a small child who's 2 or 3, what you will find is they remember that they had peanut butter for lunch yesterday. But something kind of interesting happens as we move into young adulthood and adulthood in general, and that's that despite the fact that we can form memories at a very, very early age, most of us do not have our first conscious memories at best until 3 years old, and some of us many years after that. So this is kind of interesting and kind of surprising when you think about it. It's what's referred to as infantile amnesia. So despite the fact that you and I are able to form memories as infants, our first conscious memories are around 3 to 4 years old. And there have been a variety of different ideas as to why this is. Here are a couple of things that we know. So first of all, you don't really have a strong sense of self, as in, this is me. If I look at the mirror, I'm looking at me. We don't really get that change in our sense of self until about 2 years old. And that's really important because a lot of the memories that we have are focused on this idea of, this is my life and these are the things that are important to me. If you don't have that sense of self, you don't really have much of a framework to really organize your memories around. Another thing that has been suggested for why this amnesia happens is language formation. Most of your memories have language-based content and use language-based descriptions. Infants don't really have a strong grasp of language, and so it's possible that many of those memories are pre-linguistic. They were formed without knowledge of language. And it's one of those things where when you learn a language, it's hard to go back and look at those older memories that were formed without language and make sense of them in this new way. Additionally, we also know that prior to 3 or 4 years, the brain, particularly the hippocampus, does not have the capacity to have good long-term memory formation. And all of these things working together might contribute to that infantile amnesia that many people experience. So I'm going to go ahead and stop here. We will start class by talking about cognitive development in childhood and working through the stages of Jean Piaget's stages of cognitive development. So I will see you next time. Bye.